Hey there. So far, we've introduced an Express server to support an API that will allow multiple blockchain instances to communicate with each other. Each node can call each other's APIs to gain full visibility into the status of the blockchain data in the overall system, node by node. However, it'd be ideal to have a system with more real-time capabilities. Soon, we'll need the ability to broadcast updates of a local blockchain to all the peers of the network. Now, we could achieve this kind of broadcasting functionality by sending post requests to all the nodes in the network. But maintaining a list of peers is a lot of overhead, and frankly not scalable if this blockchain network really scales, which we're expecting it to do. So to implement the real-time capability in the network, we can take advantage of what is called the PubSub pattern. Short for publisher/subscriber, this networking pattern centers around the concept of various messaging channels. These channels carry information from end to end, and the messages on these channels are sent by publishers. The publishers don't worry about who is looking at the channel. All they care about is successfully broadcasting a message on the channel itself. Now it's up to subscribers to stay aware and look out for any messages that have been broadcasted to the channel that they're subscribed to. They're not worried about who specifically sent the message. The extent of their concern is that there is a new message on the channel in the first place. This networking pattern is highly scalable. There can be a plethora of channels available in the network, but a subscriber is designed to listen to a subset of those channels, maybe around 2 select channels in the network. Similarly, a publisher only needs to be concerned about broadcasting messages to the channels it cares about. The publisher is intentional in broadcasting crafted messages to maybe 2 select channels on the network. This system requires very little overhead. This reduces a lot of the work needed for alternative network implementations, like keeping track of socket addresses, for example, which is often used in a peer-to-peer network for a blockchain system. In this implementation, real-time socket connections are open between servers, and each server has to maintain a list of peers it has made a connection with. Whenever a message broadcast needs to happen to the entire network between all peers, well, that node needs to send a direct message to every single peer that is kept track of in its list. This is a huge amount of work. Now, if this network is sending the same message to all the sockets anyway, it doesn't need this kind of targeting messaging capability. It's a little too powerful. In situations like this, when a node needs to just generically broadcast to the network in general, it's far more straightforward in the PubSub implementation for that node to broadcast that message to its concerned channel. Okay, applied to our blockchain, we're going to create a blockchain PubSub network implementation with a few channels, and we're going to start with the blockchain channel. This channel will exist as the connection between all blockchain nodes in the network in terms of real-time capabilities. Then, when an individual in the blockchain network gets new data in its local chain array, well, it will then publish its blockchain data to the blockchain channel. The blockchain data will be contained in a message, and this allows the other nodes to receive that information since they're all going to be subscribed to that same blockchain channel. Therefore, they're going to pick up the message of the updated blockchain and can then update their own local blockchain instances accordingly. The technology we're going to use to enable this is Redis. Most often, Redis is used as a rapid key value store for web applications, but we're going to use it for its nice publisher-subscriber capabilities. Now, booting up Redis with the application will be particularly straightforward, which is why we're using this technology. But the nice thing about having a PubSub implementation is that any technology that has publisher-subscriber capabilities can be substituted in, as long as it does the basic things of publishing, subscribing, and handling messages on channels. All right, with that, let's get to implementing the real-time messaging through PubSub between many nodes in our blockchain network.